Hello everyone and welcome to this month's Access Control coaching session. It is now the month of June. If you can believe it, summer is already here. My name is Cole Nebaker. I am the Training and Event Manager for PDK, and in today's session we are going to be covering door hardware. Now this is going to be pretty broad. As I was sitting here before the session started, I was thinking about more and more items that I probably could have thrown in had I had more time. And I think that there's going to probably be some follow-up to this, but I want to give you at least a broad overview of the kind of door hardware that you should be familiar with, the terminology of it, and the differences between different types of locks and door pieces. Now, as always, be sure to like and subscribe and leave your questions in that live chat bar off to the side. As a reminder, we're on a 30-second delay, so any questions that you wait until the last minute to ask, we might miss them as part of this live session. So I want to make sure I get around to them as soon as possible. So that's all the housekeeping, I guess. Let's just jump right into it. So let's begin with the structure of a door. Now we're going to focus more so on the locks during this presentation and the locking hardware, but the first component that you need to familiarize yourself with is the structure of the door. In this case, the door frame. This is the anchor that holds the entire door onto the wall. And it has a whole bunch of different materials. It could be hollow metal, kind of like pictured, and that's very common in commercial environments. It could be wood, probably more common in residential applications, maybe some older properties, or it could be aluminum, like if you have an aluminum storefront. Regardless of what material it's made of, there's going to be slight differences, maybe the thickness of the frame, or perhaps whether or not it has pathways for conduit. For example, if you have a fully wood frame, it may not be hollow. It's solid wood, and so there's not really a super intuitive way to run wiring down into the door frame to cut in a strike, for example. So just dependent on the kind of application and where you are and fire code as well, you're probably going to have different kinds of door frames. Now, I keep using the word door, but that's not technically the correct terminology. A door is called a door leaf. That is the actual unit itself that acts as the barrier, the door. It utilizes different materials, again, dependent on what it's trying to accomplish. It could be wood, it could be metal, glass, fiberglass, plastic even, and it could even be one of those cheap, like home doors that's basically cardboard. I mean, these doors are going to accomplish different purposes. And again, it can come down to a couple of things. It can come down to the finish you're trying to meet, the environment you're trying to appeal to, or perhaps even fire code. Now, the door leaf will have two different sides, and these are the vertical sides going from top to bottom. It's going to have and these are called jambs. So this is going to be called the lock jamb and the hinge jamb. So you've got a diagram on the right side of your screen there just showing you all the terminology of the different components of the door. Again, the focus of this lesson is going to be the locking hardware, so the door handle, the lock and escutcheon, things of that nature. But the door itself will have the leaf, it'll have the door frame, the casing, the jambs, and it will have the threshold on the bottom, which we're going to cover as well. Now, the hinge is what allows the door to open and close. So one is attached to the door jamb and one is attached to the door leaf. There are certain door hinges that can be electrified to allow you to access control the mechanism inside the door. So generally what that entails is you have some sort of electrified handle set, and you have basically a big long hole drilled through the middle of the door. I would probably advise you not to just attempt that if you don't know what you're doing. Doors can be quite expensive, but if you have that coring through the door, you can just pass a wire through one of these electrified hinges and pass electricity to the electrified door handle. So before building out your door, it's probably advisable, especially if it's a new build and you don't have any idea which side is which of where the door is going to swing or where it's going to open from. Make sure you identify which side is the hinge side versus the strike side when you plan your cable route. Otherwise, you are going to end up with unnecessary holes in unnecessary places. Now, a few more auxiliary components which are just worth very briefly mentioning. You may have a door closer which will assist in keeping the door closed. I highly recommend that, especially to prevent prompt. It's obviously not perfect. If an item is stuck in the door, obviously it can't close, but the door closer will at least make sure nobody inadvertently leaves the door propped open. Kick plates will prevent the bottom from getting all scuffed up and damaged. Those are typically done on high traffic doors, bathrooms, places like that. And then thresholds will help mostly with weatherproofing. Prevent water ingress in places where you don't want it, perhaps prevent smoke from seeping underneath the door, things like that. But what I really want to focus on is the locking hardware itself. Now, we're going to start with some of the hardwired and more discrete pieces of door hardware. I'm of course going to also talk about wireless locks, but let's start with the wired solution. So, as mentioned, you can have a transfer hinge which allows you to pass electricity through a hinge into the door and over to an electrified handle, which will then be access controlled. This is a good solution if you want something more discreet. It doesn't make the loud clicking sounds that a strike might make. Albeit it kind of comes at the cost of maybe labor. If the door isn't prepared ahead of time, it could become pretty labor intensive or expensive, and maybe you're just not comfortable drilling through a door, and that's totally understandable. Now, an electrified handle, while it's a good option, doesn't solve every situation. It's a handle only. If you need something like a full-blown interconnected lock, maybe it'll be difficult to do that. Maybe this will be in violation of fire code. It could be a number of things. So there are other options. You can, of course, go a more traditional access control route and do a strike or a mag lock. The alternative is a mortise lock, and I know you don't see the pigtail sticking out of this one, but it's the same principle. You may have an electrified mortise lock, which again is running power through the door hinge into the door itself. We do have other kinds as well, but I'm going to wait until we pan back from the camera and I show you the locks that I have here on the table with me. But the alternative is moving away from wiring. So instead of having power coming through the hinge, through the door, into a lock and controlling it with a standard access controller, you can instead just bundle all of the reader, the locking mechanism, and the controller into one unit and use a wireless lock set. Now, I don't want to harp too much on the wireless locks because Gus did a really good job last month while I was out of town covering the wireless locks. But we are going to cover wireless locks to accomplish our purposes today in determining the different sizes, formats, pinning, cylinders of different locks. And whether they're wireless locks or not, the principles are the same. So we have wireless locks, and those are really easy because you just throw them on the door. You put in some alkaline batteries, and you're off to the races. Different locks will have different fire ratings. Again, if you're concerned about fire code, I don't know why I said it like that. If you are properly concerned about fire code, which you should be, you can also make a determination of how long these will last in the case of a fire. Now, wireless locks are going to be these battery-powered devices that come in different shapes and formats. And again, I'm going to cover the sizes and the formats of them once we get back to the camera piece where I'm on camera here. But just know that they all have different shapes, sizes, colors, builds, cylinders, pinning, technologies, and communication methods, also very importantly. So some locks are going to be real-time locks, some are going to be offline locks, and maybe some are intermittently connected locks. The type of lock that you choose is going to be dependent on how you really want the access control system to operate. If you have a door that you access, I don't know, once a year, but you want a smart lock on it for whatever reason, a wireless lock, it may not be practical to drop thousands of dollars setting up this whole communication system to make it a real-time lock, when really it could very easily just be a very simple, one single code lets you through that door. That's kind of the idea we're going for here. And locks can fit different environments as well. So typically, the two locks that you see on the screen there, you've got a deadbolt and a cylindrical. Typically, deadbolts are pretty exclusive to multi-dwelling units, multi-family units, assisted living, places where you're going to have residential doors with a traditional deadbolt. However, you may have more commercial environments or healthcare, SMBs, co-working spaces, places where the door doesn't match the same kind of use case with a deadbolt. And in those cases, it might make more sense to just use a cylindrical lock, which will be more appropriate. Regardless, wireless locks provide a lot of value. Again, I don't want to harp too much on this because Gus did a really good job at the last live coaching session at covering some of the value adds of having a wireless lock. So this is how a wireless lock will communicate, and regardless of how, or rather what kind of wireless lock you get, the principles are the same. So again, I go back to my previous statement. We are going to use wireless locks to demonstrate the different types and technologies and use cases of different locks, but it's not exclusive to wireless locks. This is going to be applicable across the board. This is just, obviously I have the most assets available for our wireless lock, so it's going to be easiest for me to demonstrate what these capabilities are based off of the PDK red lock sets. So I'm going to skip ahead just a little bit and stop on this page right here. Now, PDK's red wireless locks are utilizing the following mechanical features. So it's going to have a conventional cylinder, a Schlage C keyway, and 6 pins. So those 3 separate items are going to be the first items I want to cover, for lack of a better word. So the cylinder on a lock can differ. So the cylinder is the piece that actually hosts all of the pins, and it's where you insert the key to twist and unlock the lock itself. So you have different kinds of cylinders. You're going to have, actually I think I have a slide for this, so maybe I should just skip ahead. I think it's one more. Yes, perfect, here it is. So different cylinders come in different sizes and they kind of vary in ease of swapping out. So as I mentioned, the PDK red locks are going to utilize a conventional cylinder, but there's more. There's a lot more. Lots of different kinds of cylinders. There's an SFIC or an LFIC. So SFIC stands for small format interchangeable cylinder, and LFIC, of course, stands for large format interchangeable cylinder. Say that 10 times fast. That is just a different size and a very interchangeable form of cylinder. Some people have preference for those. On the red locks in particular, even though they do use a conventional cylinder, you can still swap them out. It's just not the same shape, size, and mechanism for the cylinder. You also see a KIK, that is a key and knob cylinder. There are a lot more cylinders as well. So identifying what kind of cylinder you need is going to be an important first step. If you just kind of end up with whatever lock you have, you don't have a lot of choice in what cylinder you have as part of that lock. But if you're doing a full-blown preparation of prepping a building for install, chances are either you or the end user already has in mind what kind of cylinders are going to be used. Are they going to be master keyed so that the maintenance team or the administrative team can come in and very easily access each one of those apartments? Or is it going to be unique keying per door? I mean, if you just go to distribution and pick up a lock off the shelf, that's how it's going to be. Each one's going to come with a unique key, and you're not necessarily going to have control over what kind of keying that is. Now, a separate item with this is the pinning. So the pinning is going to be how many pins are inside of the cylinder itself. So in other words, how many little notches are on your key. So as covered in that previous page, on the red wireless locks, the red locks utilize 6 pins. So if you look at one of the keys from a red lock, you can identify 6 distinct places where the pins will rest on the key. Other locks, especially higher security locks, are going to have more pins. I put some very common pinnings here, 4, 5, 6, 7 pins. It's possible to have more, and if you really cheap out, you can get less than 4. I wouldn't recommend that. That pinning is going to either, again, be predefined, where you are pinning everything in such a way that you can use a master key, or it could be just random. Again, if you go and pick these locks up off the shelf, they're going to be random. Although I will say they will all universally have 6 pins. Okay, so swing it back to me, Keith. We are going to cover the different kinds of locks and the anatomy of a lock. Now, there was a video played last time that covered how to assemble one of these, and it covered all of the terminology from the inside out. I don't want to go into that. I just want to go into the basic names of each of these components, so you can easily identify what is being discussed, both in documentation and speak intelligently in front of your users. So the first lock we are going to use is this cylindrical lock. This is a very standard cylindrical. This is the red lock, of course, but these components that it's using are going to be universal across different kinds of physical lever sets. So you have the handle, of course, and then you have what's called the escutcheon, and that escutcheon is going to be the lock body itself, and it is this whole entire metal body that you see associated with the lock. We refer to that as the escutcheon. So the escutcheon is generally, like, I would just say an easy definition for that is the body of the lock. Now, attached to the body of the lock, you have the levers, which can be released by the little pin. You probably can't see that on video, but there is a little pinhole inside of there that allows you to release the levers. Perfect, Keith. That's perfect. Thank you. So those can be removed. Now, you also have on a cylindrical something called the latch bolt, and that is this latching mechanism that goes in and out, and that is what latches the door to the door frame, the door leaf to the, I've already forgotten the correct terminology, but the door frame, sufficient to say. Now on the other side, we have the reader. So this is unique to wireless locks, if you're going to have a reader or not. If it's a standard not smart lock, this is going to be just a blank face, or maybe it will be much smaller. It'll just be a small metal escutcheon around the door handle itself. And then finally, the most important part is the cylinder and the keyway. Now I have the key here with me, so I'm going to put it up here so you can kind of see the pinning I'm talking about. So that has 6 distincts, and I promise this is a marketing unit, so you will not benefit by copying this key in any sense of the words. I feel very comfortable showing this on camera. This has 6 pins, and you can see it is unique to this particular lock, and then the deadbolt and the interconnected that I'll show you. But this is a conventional cylinder, 6 pins, and you can change it. All you need to do is take the lever off, and then you can actually just push it through the backside of that lever. So this is about as basic as it gets. I mean, the cylindrical is very straightforward. You do have some back plates behind here, which I didn't show because I'm not disassembling the lock. There's some back plates on here which hold it to the door. There's some through screws that hold it flush against the door. You have your handles, escutcheon. You have your wrong side, batteries, reader, and the controller is also built inside of there. Okay, so that's your anatomy of a cylindrical. Now I'm going to move over to a deadbolt. Now, a lot of things here are identical. You still call the lock body itself the escutcheon. However, instead of calling this a latch bolt, we instead call it a deadbolt. Fairly self-explanatorily, this is called the deadbolt. And instead of having levers and handles, it instead just has a thumb turn. And that's what allows you to activate and deactivate the lock itself. So same principle, still has the conventional cylinder, still has, and again, I feel very comfortable with this, it still has the 6 pins. And you can see that this one is very different from the cylindricals. I guess if I hold them up both side by side, you'll see, there we go, everything's backwards on the screen. That's very disorienting. So you can see they're 2 different keys. They're uniquely keyed. If you want something with like a master key, you're going to have to probably custom order that. Otherwise, you can swap out the cylinder and the core itself. Okay. Now, finally, I want to cover the interconnected beast here. Yeah, you have to zoom out for this one. So, the interconnected actually connects through the escutcheon on the outside of the door. And that's, I want to emphasize that because if you have something like a mortise or if you connect something on the inside of the door, it's going to be a very different installation process compared to this. All of the interconnected components are inside of the escutcheon on the, what side is this? The secure side of the lock. And you can see it has both a deadbolt and it has a latch bolt. Now the difference here is that the latch bolt and the deadbolt are connected inside of the body. So when we, let's do this way. Here we go. So when we open the door from the inside, you can see both the latch bolt and the deadbolt retract. And then the latch bolt re-extends, the deadbolt does not until I relock it, at which point you will need to unlock from the inside or the outside. So it's a little more involved. It's nothing complex, it's just 2 in 1. So instead of just having a separate cylindrical and a separate deadbolt, and instead of having, oh cool, you can see it's set to auto lock there. Instead of having 2 separate mechanisms, you're combining it into one single mechanism. Otherwise, fundamentally, it's the same. The connections inside of these are going to be the exact same as the connections inside of those other locks. It's just going to be in a different form factor. Functionally, locks all operate basically the same way. It's just a matter of how they attach to the door, what technologies they use, what kind of keyways and cylinders. And you'll notice too that the cylindrical does not have the lock cylinder inside of it. Only the deadbolt does. So that's another key difference about this. You're still only dealing with one key, but instead they're connected together and it's all done up here. I keep missing it. Very hard to work on camera, working off everything that's going backwards. So that is, those are some of the principles of your locks. They're all going to have lock bodies. They're going to have some way to interact with the door, whether that be the thumb turn or whether that be the cylindrical handle. And I don't have a mortise here to show off to you, but just know that a mortise is just a different kind of lock. And it takes up a large portion inside the door and has a different mechanism that holds it to the door. Otherwise, exact same principles. You have the lock cylinder, the lock keyway, the core, and then you have the escutcheon on the outside. You're going to have a handle set associated with that. And all you need to do is screw it all together That's pretty much it. It's pretty easy. So Keith, go ahead and jump into the rest of this. We're just going to wrap up with some of the common door components. These are your traditional access control, right? So you may have maybe a, I don't know, for lack of a better word, a dumb cylindrical lock on the door where it remains locked all the time. It doesn't have any smart components, it doesn't have any electronics, whatever, and you want to be able to control that door. Now, I guess that was kind of a bad time to lead with that example because mag locks are generally just going to be handles attached to the door, not necessarily a lock component, but mag locks just operate based off of electromagnetism. They're just going to receive a current flowing through them. It's going to produce an electromagnet and it's going to hold the door shut. So mag locks use a variety of different forces. They're probably the more impressive in regards to physics in how they operate. But they're going to have a holding force, and that's dependent on how much current is passing through and how strong those electromagnets are. So the holding force is the highest load possible. Now, if you run doors, what's the word I'm looking for, parallel to each other, maybe you have a mag lock on one side and a metal piece on the other. If you run them parallel to each other, that's what we call shear force. And that will be how much shearing the mag lock itself can take. And then, of course, pulling forces. So there's a lot of different forces associated with mag locks. However, there are much fewer things to worry about with a strike. So this is where my dumb cylindrical comment comes back into play, because this actually is where you probably would use one of those. So if you have a non-smart lock and you're just looking for a very standard access control solution, you're probably going to have some sort of a cylindrical lever set on a door, and you're going to have a strike. So you will run the wiring for the strike through the door frame, and you will electrify the strike every time you want to activate it, or vice versa. It depends whether it's a fail-safe or a fail-secure strike. But the principle is basically you provide a voltage, it unlocks a solenoid, and it allows you to freely pull on the door. You don't necessarily turn the handle because the handle's locked at all times. You pull on the door and it allows you to freely pass the latch bolt through those retainer mechanisms on the strike. You have different kinds of strikes. You have rim strikes, recessed strikes, all sorts of strikes. Assa Abloy, for their Hess strikes, makes an entire poster, if you can believe it. It's a full-blown poster of different kinds of strikes. So there's no limits to the number of strikes you can utilize. Now, something that will be useful across the board, regardless of whether you're using a wireless lock, an electrified handle set, or even a standard door strike, is a latch guard. That is going to prevent people, or rather it's going to deter people from reaching in with a pick and manipulating the latch bolt. Now, the reason I changed my statement midway there and said it's going to deter is because it's not foolproof. Obviously, there are people with the skill set and the knowledge to bypass this. But this will be a good tool in your arsenal to make sure that you're taking every preventative measure possible to make sure that people are unable to bypass that door. Crash bars are an important tool, especially if you're using door strikes. That will allow free egress out of those doors by just bypassing the door strike entirely. Even if you have no power and the strike doesn't activate a solenoid, doesn't matter. This is a mechanical form of override and allows you to retract those latching mechanisms and bypass any locked door. So regardless of what kind of locking hardware you have on a door, you're going to still need to make sure that people have free egress out of that door. Okay, so with strikes, you have a few different forces, not nearly as many as mag locks, but you're going to have a holding force, which is how much it can hold. And then you have the static load of the door being exerted on the strike that you'll want to account for as well. Fortunately, lots of strikes have, well, I say lots of strikes, all strikes have a cutting template that allow you to cut into the door frame. Although, if you're not a locksmith, I would probably advise, don't just go in and try this. It's again, another very expensive mistake. Same deal as with a door leaf. If you buy a really expensive door leaf, don't just go through and try to core through the entirety of it. If you punch a hole through that door, it's going to be you and your company that's on the line. So if you're not comfortable cutting a strike or coring through a door, probably outsource that to a locksmith. And finally, just to recap, fail-safe versus fail-secure. Fail-safe is going to be a power that, it's a device that requires constant power to remain locked, and that's a prime example of a mag lock. It is using that constant current to provide an electromagnet, and that current is what keeps the door held closed. As soon as you cut power, that door unlocks. A fail-secure device is probably going to be an example of most of what we talked about today. If power is lost, it's going to remain in the secured position. So strikes are very commonly fail-secure. They can be fail-safe, but generally when they lose power, they're going to fail in the locked position, which means you're going to need that mechanical form of override. Similar to an electrified handle, if that thing loses power, there's nothing to activate the solenoid to unlock that door. So again, you're going to have a fail-secure device. As with any of these wireless locks, as soon as you lose battery, it's mechanical key overrides. You still have free egress. The handle still grants you the ability to exit that room, but you don't have the ability to have the batteries unlock the door anymore, and it does fail in the secure position as well. So with all of these, just make sure that you always account for fire codes. And with some states and some jurisdictions, you even need to make sure that you have appropriate overrides even for these. I believe it's California that doesn't just allow a standard thumb turn deadbolt. You also have to have the handle associated with that, the interconnected lock associated with that. And that's to meet fire code for residential premises. So there's a lot of considerations. Now, we've covered everything from the door frames to the jambs to the leaves to some of the door hardware that attaches to the doors, and we've covered everything from cylinders, pinning, lock formats, and then traditional hardwired access control. It's been a lot. You can probably see why, as I was sitting here, I was just kind of like, well, we probably need to do a follow-up to this. But if anybody has any questions, be sure to leave them in the comments right now, because we're on a 30-second delay and I can only blab for so long before I run out of things to say. But while I wait for people to type in their comments, we appreciate you jumping in. We do these coaching sessions once a month on the first Tuesday of every month, and we have some excellent coaching sessions coming up on some really interesting topics. So I highly encourage you to subscribe to the PDK channel, and if you don't want to do that, that's fine. We also have a registration page on the website where you can just put in your details and we'll send you an email reminder before we do these coaching sessions. Now, if you watch these coaching sessions after the fact, you probably don't get the opportunity to leave your questions. So if you have questions, you can send them to sales, S-A-L-E-S, @ProdataKey.com, or you can call them if that's your preference. I don't usually like to talk to people, but if that's you, that's fine. And that's 801-317-8802. Perfect. So we do have a question that filtered in here. What is the airspeed velocity of an unladen swallow? And the answer to that is a European or an African. So, Mike, I appreciate your comments there. We love having you in these sessions as well. So, if there's no further questions, thank you for jumping in, and we will catch you at the next coaching session in July.